Good evening, friends. Welcome back to Education Data Analytics. So we have started with applications of education data analytics. So we have seen what are the different applications where we can use the student data, where we can use the university data. We can evaluate university data marks. Okay, so all these are different applications. So we have seen that we can build specific tools related to education data, such as learning management system, learning analytics, by using education data analytics. So to start any project, like we are looking into education data. So to start any project from any domain, we are going to have a specific project management methodology. So we are going to have a project management methodology. So specifically, when it comes to data science and machine learning, we have a project management methodology that is called as CRISP MLQ, okay, cross industry standard process for machine learning, which comes with quality assurance. So we have seen what are the different phases that we have. So yesterday we have looked into different phases of CRISP MLQ. So the agenda that we have seen is like we will be looking into what are the different stages of analytics, what is CRISP MLQ methodology, inferential statistics, unsupervised and supervised learning, what is data split, error functions, overfitting and underfitting. These are the different things that we are going to look at. So let's do certain some recap and let's begin the topic. So we are looking into different stages of analytics as we have seen yesterday. So the descriptive analytics, the first stage that we have is descriptive analytics. So here the question that we are having is why? Sorry, we are going to ask what happened in the data. So the question that we are going to ask here is what happened in data. So the next question would be why something has happened, right? So basically the first question would be what happened in data. Now we are looking into why something has happened, right? So we have seen certain examples like how we are going to find what happened in data. So we will be looking into different graphical representations, and by using these graphical representations, we are going to see the trend in the data. Okay, so if the data is we have a increasing trend, okay, we have a or the values are decreasing. Okay, so the trend in the data that we can observe here, okay, like if the values are either increasing or decreasing. So this fluctuation can be noticed by using different graphical representations. So once we know the descriptive analytics, what happened in the data and why it has happened, we will be looking into predictive analytics. So we are going to predict. So the third stage we have here is predictive analytics. So we are going to use the machine learning models. So the model building part, okay, will start from this particular stage. Then we'll be looking into prescriptive analytics. So based on the analysis, based on the predictions, what we are going to prescribe in the business. So that is something we are going to look into when it comes to the stages of analytics. So yeah, when it comes to project management methodology, so CRISP MLQ, okay, here we have something called as CRISP MLQ. There are 4 different stages: business and data understanding. So we have to understand the business. So here in this case, we are looking into educational data that is coming from the education industry. Data coming from education sector. So we have to understand the business. Okay, what we are trying to look into. So is it a data coming from a university and it want to predict something related to the marks, okay, university marks, or maybe the performance of the students, maybe the behavior of the students. So we have to understand the business. So the first stage that we have is business and data understanding. So then we have data preparation. And the next stage that we have is model building and tuning. Then we have model evaluation, deployment and monitoring and maintenance. So we have seen that how do we use data science in education? So this is something we are looking into education data analytics. So what do we have here? We can assess the student data. Okay, for assessing student data, we are going to use data science. Social and behavioral skills. So for assessing, for analyzing social and behavioral skills, we are going to use data science. So for looking into parents' role into children's growth and development, okay, that is one factor we are going to look into. Maintaining the curriculum. So to maintain a particular curriculum, we are going to look into data science. So in the same way, instructor performance. So to know the instructor performance, I can use data science. Students demographics also. To do certain research on student demographics, we can use data science. So we have seen what is unsupervised learning. Okay, so the flow chart here. So basically I have some data, and in this data, we do not have any target variable. So this is the data we have. So these are the values we have. Okay. So we are looking into the input data and output data. So we have the input data and we have output data here. So what happens here? So basically we try to find the relation between the input and output data. Okay. But if we do not have output data, okay, in the output column in the data, so it is called as unlabeled data. Okay, we call it as unlabeled data. So what we have to do in case of unlabeled data, we have to use a model called as unsupervised learning. So we'll be using unsupervised learning in case of data that doesn't have any label. So it's a unlabeled data. So basically we are going to have some historical data. From the historical data, we are going to feed this historical data to a machine learning model, and we try to get the rules and patterns from the data. And what we are going to do with these rules and patterns that we have drawn from this data by using a machine learning model, we are going to predict, okay, we are going to use this for prediction. We're predicting new data here, and we are going to get a predicted outcome. So we have supervised learning. So the only difference, okay, the difference that we have seen is if I have a data, and in this data, if we do not have any input variables, sorry, if I have only input variables and if we do not have any output variable, so here we are going to use something called as unsupervised learning. So in the same way, if I have a data and here if we have input variables and as well as I have output variable, okay, so this is called as supervised learning. So what we are going to do here, so basic equation that we have in data science in machine learning is y is equal to f of x. Okay, so we are trying to find the relation between x and y here. Okay, x is the input data and y is the output data. So let's understand the flow here. Okay, when we have, so basically we are going to start with a historical data, And then we take certain amount of random sampling. We do certain amount of random sampling here. So training and validation is something important. Okay, training and validation is something important. So that we are trying to look into here. So if I want to train a model, okay, if I want to train a machine learning model here, so we start with historical data, we collect random sampling, and here we are going to divide. Okay, here we are going to divide the data. Okay, here we are going to divide the data into two different data sets. One is called as training data set and the other is called validation data set. So we use training data set to train a machine learning model, and we use validation data set to, once we train this model, I am going to get certain amount of accuracy. Okay. Now I am going to retrain this model. Okay. I am going to retrain this model by changing certain amount of hyper parameters. Okay, I'm going to retrain this model by using certain hyperparameters. So maybe when I tune this model with hyperparameters, I may get 95% accuracy. Okay, so now I am going to combine the complete data and again I am going to retrain the model. So now if I am getting on the complete 100% of data, if I am getting 95% accuracy, so that model, okay, that model that is giving me the best accuracy, I am going to apply on my new data. Okay, this data is called as test data. So we'll be looking into the evaluation part. Okay, so how we are going to evaluate the data here. So this is the flow that we have in supervised. So we have seen how the data split works. Okay, so data will be divided into training data set, validation data set, and testing data set. So training data set is used for building a model, and validation data is used to fine tuning the model. Okay, we are going to fine tune the model by using different hyperparameters. And finally, this data will be combined. Okay, if the data is working, okay, so this data will be combined and we are going to build a final model. That model will be used for testing. So here we are looking into something called as error function. Okay, here we have a confusion matrix. So errors and accuracy measures. Okay, these are certain things that are very important. So basically, we have to understand one thing. So when I have data, so basically, based on the data that we have here, if I have only input variables, if I have only input variables, I am going to use unsupervised learning. Okay, so if I have input values and output values, I am going to use supervised learning. Right? Now again, when we are in supervised learning, we are going to evaluate the model. Okay, there are two types of models that we are going to look into based on the data that we have here. So when I have, so this is the actual data we have. This output could be a categorical value or it could be a continuous data. Okay, it could be a categorical value or it could be a continuous data we have. So how to evaluate when we have a categorical data, how to evaluate when I have a continuous data. So that is something we are trying to look into. So we are going to take, we are going to use a method called as confusion matrix here. So what do we have here? Here we are taking a categorical value. Y is categorical. So what I'm going to have here, this is present and this is actual. So this is the actual class I have. And here I have predicted class. So I have actual class and predicted class here. So what I'm going to have, so when we have the data here, so let's take the same data, okay, X and Y value I have. So Y value, this is my actual class. And by using the model, I am going to predict these values. So this is my predicted class. So what is happening here? Okay, for example, if we take that, if it is this is present, here we are having, maybe I have predicted as this is present. If this is absent, I have predicted as this is absent. And if this is present, if I have predicted that this is absent, so that is an error here. Okay, so how to evaluate this error? So we are going to compare these values. If I compare these values, so we are going to use comparison operator here. Okay, like when dp is equal to this is present is equal to this is present, I am going to get true. Okay, so if this is absent is equal to this is absent, I am going to get true. But then it is this is present, but we are having this is absent, that is false. Right? So now we are going to take this data in 4 ways. Okay, there are 4 possibilities that we can see here. First possibility, as I said here, so the first possibility that we have is this is present and my model says that this is present. Actual value, predicted value. So let me take it as A and let me take it as B. So in the same way we have this is absent and my model predicted as this is absent. One more condition that we have is this is present and my model predicted as this is absent, and the final condition that we have is this is absent but my model predicted as this is present. So these are the 4 different conditions that are possible here. So among this, we can see that if we are saying this is present, okay, and we have this is present, this condition is called as true positive. Okay, this condition is called as true positive condition. It's true, okay. And in the same way, we have true negative. And when we have, it's like we are saying patient with disease is told that he or she does not have disease. Okay, so this condition, that means this is present, but we are saying that this is absent. So this condition is called as false negative. And finally, we have false positive. So these are the 4 conditions that we can see. Right? So true positive, when we say true positive, patient with disease is told that he or she has disease. So for example, we can take the same example as student is, okay, we have a data where student passed and my model is saying that he has passed. Okay, and the second condition is like student failed and we are saying that student failed. So both the conditions are true. Okay, so we are giving true positive, true negative. Okay, and the second condition we are saying that student so student passed, but we are saying that student failed. Okay, and in the final condition we are saying that student failed, but we are saying that student passed. So these are false negative and false positive conditions that we have. So we have few more measures that we can use to evaluate the classification model, such as precision. Okay, so in precision we are looking into true positive divided by true positive plus false positive. So here we are going to look into the probability of correctly identifying a random patient with disease as having disease. And the second condition that we have is sensitivity. Okay, so we are going to call it as recall or hit or true positive rate. And we are going to get true positive divided by true positive plus false negative. So what are we trying to find here? The proportion of people with disease who are correctly identified as having disease. So that is one condition. We have specificity, okay, true negative rate. So true negative divided by true negative plus false positive. Proportion of people with no disease being characterized as not having disease. So these are four different conditions that we have. Okay. So we are going to calculate the FP rate, okay, the false positive rate, where 1 minus specificity divided by false negative. So, and this is called as type 2 error, basically. This is called as type 2 error. And we are going to calculate the F1 ratio. So, 2 into precision into recall divided by precision plus recall. So, 120, okay, 120 will be the value of F1 score, and it measures the balances between precision and recall. So in case of, so the condition that we have seen, that is related to a classification model. So now in the same way, if we have a regression model, if I have a regression model, so what we have to do in this condition, if I have a regression model, so what I am going to have the data as, I am going to, if so, let's take this is the data. So this is the actual data I have. This is the forecasted values. So the actual data minus forecasted value give me a negative value. In the same way, I am going to get a positive value here. I am going to get a negative value, and I am going to get a positive value. Right? So when I take the mean value, I am going to get a 0 here. Right? So what we have to do, so the mean value, the mean error that we are taking, that we are going to show it as the error for that particular model. So what we have to do, so what is the condition? Okay. So there are certain methods that were developed to rectify this particular issue. So mean absolute deviation. Okay, we are going to use something called as mean absolute deviation. So where I am going to keep a absolute value, right? So when I keep this absolute, okay, when I make the error value, when I keep the absolute value, automatically it converts. Okay, the negative value converts to positive. So that is one thing we can do. And we have mean squared error. Okay, we have something called as mean squared error. So based on the units, okay, when we have the units here to rectify that issue, okay, so we are going to use certain methods called as root mean squared error or mean absolute percentage. So now we have seen that the model could be a classification model. Basically, what we are going to have, I am going to have data. So when we have data, we are going to first work on EDA process. Then I am going to do the data preparation. Once we are done with the data preparation, we work on data split. So let's suppose that we are taking only training data and testing data. So training data is 80% and testing data is 20%, for example. So I am using my training data for model building. So this model could be a classification model or it could be a regression model. So when we have the output as, so when we take this data, when we have output as the categorical data, there we use classification. So when we have regression, we use in case of regression, we have output as continuous data. So from here, okay, now I have applied this model. Now I am trying to evaluate this model. So when I am trying to evaluate this model, so in case of classification models, we will be looking into accuracy factor. So here we will be looking into error function. So when it comes to accuracy and error, maybe we have two values here. Okay, so here maybe let's take the accuracy value. I am getting 90% accuracy here in my training set, but when I'm testing on my testing data, I am getting only 70% accuracy. So what is happening here? My model is working good on my training data, but when it comes to testing data, my model is not working. So that is one thing. So this condition, okay, this condition that we are seeing here, it is called as overfitting condition. And there might be a situation where my training data set itself, I am getting only 70% accuracy. So what is going to happen? So my model is failing in training phase itself. So we do not require to go to testing phase. This condition is called as underfitting condition. So when it is right fit, when I'm having something like 91% of accuracy in my training data, and if I'm getting something around 89% in my testing data, it is called as right fit. So these values should be very low. So maximum margin should be like 5%, not more than 5%. So that will be considered as the better fit, right fit. So what is overfitting? Okay, a statistical model is said to be overfitted when we train it with a lot of data. So if we use more data also, it may lead to overfitting. Okay. So when a model gets trained with so much data, it starts learning from the noise and inaccurate data entries also in our data set. So then the model does not categorize the data correctly because of too many details and noise. And when it comes to underfitting condition, okay, a statistical model or a machine learning algorithm is said to have underfitting when it cannot capture the underlying trend of the data. So underfitting destroys the accuracy of a machine learning model. Its occurrence simply means that our model or the algorithm does not fit the data well. So these are the two different conditions that are very important. We should be looking. So when do we have overfitting? So when we have very high variance in the data, there is always a chance of overfitting. Okay, when we have more error in the data, there is always a chance of underfitting. So here we can see. So the first condition we are looking into the regression model. So these are the different, these lines that we are seeing, these are the different models that we are looking at. So first model, it's a very simple model, but you can see that we are this straight line that we are seeing, okay, the red line that we are seeing here, it is a prediction. And and the distance between the prediction, so distance between these points and the prediction values, we can notice that there is a, so this is called the error. Okay, this is the error value that we are getting here. So there is a lot of error that we can see. So for example, if I take this data and for this model, I am getting 10 as the error. Okay, so when I compare this model to the second model that we have, so if I look into the data, I can see a curve here. Okay, the model where we have made certain changes to the equation here. So what I'm going to get, for maybe I'm getting 5 as an error here. Now in the third condition, we can see that my model is reaching to each and every data point that is present. So what could be error here? The error will be 0. So this condition is called as underfitting condition, where I have more error. Okay. So this condition could be called as a, so this could be called as a right fit model. And the last model that we are seeing here is a overfitting model. So when we have a new data, okay, when we are taking overfitting condition, that means when I have a test data, definitely the error will be, the variation will be good when we look at it. So what about the classification? Okay, here we are having a, when we look into classification, here we are going to take the data. So these are the different values that we have here. Okay. So these data points that we are seeing here, these are the different data points we are seeing here. So I have drawn a straight line here. So I'm just trying to separate these two. Okay. So just I am trying to draw a line here. I can see that there are still certain points that are here. So if I look into the accuracy, maybe the accuracy could be 80% here. Let's see the next one. So here we have changed the line here. We have changed the equation. Okay, we have changed the model here. So we are looking, maybe we have added certain hyperparameters. So we can see that only two values I couldn't able to separate, but most of the values are separated. So maybe we can give the accuracy as 90%. So the next model that we can see, each and every data point that we have separated here. So here the accuracy is 100%. So in this condition, this is a overfitting model. This is a underfitting model. This is the right fit. So how to choose the training data set, validation data set, and testing data set. So what do we have here? For balanced data sets, split randomly to avoid bias, take 60% into training, 20% into validation, and 20% into testing. So when it comes to, when we have only training and testing data sets, 80% will be taken for training and 20% data is taken for testing. When we have a large test set, we are going to estimate future error as accurately as possible, and large training set better estimates how large should a training set be. Okay, so that is something we have seen, okay, related to CRISP MLQ methodology and the evaluation methodologies that we have here. So let us look into the second topic that we are having here is EDA. So we have seen the CRISP MLQ methodology here. Okay, so we have started looking into project management methodology. So where we have seen CRISP MLQ, the cross-industry standard process for machine learning with quality assurance. So here we are looking into, so we have started with business understanding. So in business understanding, we have seen, we have to start with recording business objective. We have to record business constraint. Then we'll be looking into business success criteria, machine learning success criteria, and economic success criteria. And it is recommended to write objectives and constraints using 2 to 3 words. And also it is recommended to use the data optimization terms like minimize and maximize. So when it comes to project charter, this is the first document which we get okay, prepared on any project, and the high level product characteristics that we have here, high level project requirements we have here, we are going to include, and summary milestones we are going to have, summary budget, key stakeholders, and high level risks. These are the certain details that we are going to add in project charter. Then we are looking into data types. Okay, when it comes to data understanding, so we have data types and data classes. So we have data types and data collection. So the two high level data types that we have are continuous data and discrete data. So when it comes to continuous data, again the continuous data is divided into interval data and ratio data. So what is continuous data? So the data which can be represented in decimal format and it makes sense. Okay, it is called as continuous data. So when it comes to ratio, okay, so ratio is objective. Okay, so ratio data will not change from one place to another place, and it is the most preferable data type of the data science in data science. So the examples we can say as weight, height, age, all these are different examples of the continuous data. The same way we have interval data. Interval data is subjective. It changes based on the opinion of a person. So the best example could be temperature. And we can also take IQ rating. And in the same way, we have discrete data. The other data type that we have here is discrete data. And when we have discrete data, the data is divided into count and categorical. So in categorical data, we have binary and multiple. We have binary and multiple categories. And again, the multiple categories data is again divided into nominal and ordinal. So the least preferred data type is nominal, and examples we can say colors, gender, jersey, all these are different examples. And when it comes to ordinal data, so the military ranking, okay, so we have the military ranking here. This could be taken as the ordinal data. Clothing, size, or class rank. These are different values that we can take in ordinal data. So qualitative versus quantitative data. So there are certain categories we have seen earlier, like in continuous data, we are taking the length, okay, or we are taking weight. It is a quantitative data. When it comes to qualitative data, something like if you are asking how is the food, okay, good, worst, bad. So these are different categories, okay. So these categories comes under quantitative analysis, sorry, qualitative analysis. So in the same way, we have structured data versus semi-structured data versus unstructured data. So what is structured data? So structured data is the data which can be represented in tabular format. So examples, MySQL database, Microsoft SQL, Oracle database, all these are structured data. And when it comes to semi-structured data is that data which is a combination of both the structured data and unstructured data. So the example could be HTML and XML, etc. So this could be it is a data, okay, which is not provided in tabular format but can be easily transformed into structured tabular format. So when it comes to unstructured data, okay, unstructured data cannot be placed in its raw state in tabular format. So we have to change the data. Okay, for example, we have videos, images, audio or speech, texture. So we have to convert the data and we have to work. So again, the data is divided based on the volume, okay, based on the volume that we have. So the data is again divided into two types. So one is big data and other is non-big data. So here we will be looking into four V's that are very important: volume, velocity, variety, and veracity. So when it comes to volume, we look into huge volume of data. Velocity, data generated at a rapid speed. Variety, video, images, audio, text, etc. And veracity, uncertainty in data. So in the same way, the structured data is again divided into three types. One is cross-sectional data. So in cross-sectional data, the date and time and the sequence in which you have data does not matter. So, and the data will have multiple variables. When it comes to time series data here, so date and time and sequence in which we have data, okay, it matters. So data should always be arranged in a sequence, ascending or descending order. And we have a single variable and one time variable for sorting in sequence. So when it comes to longitudinal data, it's a combination of both cross-sectional data as well as the time series data. And we have balanced and imbalanced data. When it is a balanced data sets, so we get the balanced data sets by using a method called as simple random sampling. Okay, when we have imbalanced data sets, there are many different methods we have. When it comes to random resampling, okay, there is a method called as random resampling, where there are certain times where we have undersampling or we do oversampling. Or there is a method called as bootstrap resampling. We have a k-fold cross validation method. We have repeated k-fold cross validation method, and we'll be using like stratified k-fold method. Leave one out, okay? N-fold cross validation, smoting, like synthetic minority oversampling technique, or MS smoting, modified smoting, or cluster-based sampling assemble techniques. These are the different techniques we are going to do. So in the same way, we have offline or batch data versus live streaming data. So these are different data types we have. And when it comes to data collection, okay, so as we have to understand the data, so we are going to measure the data, we are going to do the analysis from this measurement, and by using this analysis, we are going to find the trends and patterns in the data. So as the data types are very important, in the same way, data collection is also very important part of data understanding that we have. So what we have here, so there are two types of data sources that we are going to have. One is primary data source and the second is secondary. So primary data source, data collected at source. Okay, the examples are surveys, design of experiments, simulations, web scraping, social media extraction, IoT sensors, etc. So IoT sensors data can also be the secondary data. And what are pros? Okay, get data for exact variable of interest. Con is costly and time consuming. So here we have like in case of data collected before, okay, secondary data source. So it's a readily available data. So RDBMS, CRM, FRM, all SQL databases, all these comes under our secondary data sources. So what are pros here? Data is easily available, but what are cons here? Data may or may not have variable of interest. So these are different data collection methods we have. So along with this, we have data version control. Okay, so modification on the data set should be documented. Okay, this is one way of collecting the data. So whatever modification that we are doing in the data set, that will be controlled. And data description. Okay, So the data should be described by their statistical properties, information about format, units, etc. of each input is required, and this is something related to the domain knowledge. So when we get the data, we should be looking into all these factors, whether we have data description or not. So what are the data requirements that we have here? So the requirements can be the expected feature values, a range for continuous features or a list for discrete features, and the format of the data. Requirements have to be defined carefully to include all possible real world values. Data verification is also very important. Okay, the initial and added data have to be checked according to the requirements. So the best practice is to use data exploration techniques to investigate the sample distribution of the data. So these are two things that are very important, and we follow these two to get better results. So we are looking into exploratory data analysis and pre-processing. Okay. So we have completed data preparation. So sorry, we have started with CRISP MLQ. We have seen the applications of education data analytics. Then we have seen CRISP MLQ methodology. What are the different evaluation methods we have? So what are the different learnings that we are going to look into? What is data mining? So these are the different things that we have already covered. Now we are looking into EDA and pre-processing. So the agenda that we have here is exploratory data analysis and data pre-processing in education analytics. So what is exploratory data analysis? So exploratory data analysis refers to the critical process of performing initial investigations on data so as to discover patterns, to spot anomalies, to test hypotheses, and to check assumptions with the help of summary statistics and graphical representations. So when it comes to EDA starts by asking some basic questions of data sets to make an initial assessment of the data structure and quality to facilitate a plan of attack. So these questions include: is there an existing unique record we have? Are fields populated with numbers, dates, or alphanumeric characters? What is the distribution of numeric values? How many values exist for categorical fields? How many fields have been left blank? How are multiple data sets related? So all these details we are going to ask as a questions in case of exploratory data analysis. So what do we have in EDA? So when it comes to EDA, exploratory data analysis consists of graphical analysis and statistical analysis. So what do we have in graphical analysis? So we have univariate analysis. So the analysis on one variable to summarize the variable. Example, we have bar plot, histogram, box plot. All these are univariate analysis. These are the different graphical representations where we use only one variable to summarize what is happening in that particular. And we have bivariate analysis. So bivariate analysis is about the two variables to determine relation between them. Example, scatter plot. Okay, multivariate analysis of multiple variables to determine interrelationship between them. Like we have the pair plot and heat maps. So exploratory data analysis consists of graphical analysis and statistical analysis, as we said earlier. So here we are looking into statistical analysis. The first moment business decision that we have, okay, it is also called as measures of central tendency. So what do we have here? Example, we have mean, median, and mode. And the second moment business decision that we have here is measures of dispersion. So we have variance, standard deviation, and range. And the third moment business decision is measure of asymmetry. So example, we have skewness. And the fourth moment business decision is measure of peakedness or tailness. Example, we have kurtosis. So there are certain pre-processing techniques that we are going to follow, like typecasting, handling duplicates. We have outlier analysis and treatment. We have zero and near zero variance, discretization, missing value. Like we have dummy variable creation, transformation techniques. We have standardization. We have string manipulation. All these are different pre-processing techniques that we are going to use to process the data. And when we look into text mining, okay, where we are going to deal with the text data, for example, the text analytics involves automatically extracting semantic information from archives of biomedical text or any text, okay, abstracts or medical records and patients, okay. So we are going to analyze this data. Okay, so there are certain methods like tokenization, normalization, noise removal. All these are different techniques we are going to use when it comes to text pre-processing. So, what are the different things that are involved here? Like we are going to remove HTML tags if we have, remove extra white spaces, convert accented characters to AXI characters, expand contractions, remove special characters, lowercase of all text, convert number words to numeric form, remove numbers, remove stop words, limitation. All these are different techniques that we have. So let's take an example. Okay, when we are applying EDA, okay, let's practice the EDA on education marketing, for example. So what are the different attributes we can have? We can expect here maybe company, country, university, state, year, courses, right? So these are the different, like maybe if you are taking a placement data, for example. So we'll have the company also, right? We'll have different student names. Okay, we haven't taken certain details here. So if I look into university analysis here, are there any extreme observations present in SF ratio? Right? So support your answer with a plot. So what is the plot we are going to take here? So if I want to know the extreme observation, we will be looking into box plot. Okay. So in the same way, is the variable phi, okay, is it skew or not? Support your answer with a plot. So what is the plot we are going to take? We are going to take a plot that is histogram. And the metric I am going to use is skewness. Again, okay, it could be is a positive skewness or negative. So we have multivariate analysis. So does this scatter plot of phi and SAT score reveal potential outliers? Which country has the highest number of companies? If I'm handling non-numeric data, right? Create a dummy variable for each category in countries. Normalization, scaling the data set is needed for making data points, okay, generalized. Like if I am looking into transformation techniques, so remove the skewness. We can use various transformation techniques such as log transformation and square root and cube root, etc. Thank you, friends. This is something we have today. We will be looking into more detail into EDA techniques tomorrow. Thank you, friends. Have a great day.